What's up? Mr. Wicklehouse, and today we're talking about similarity proofs, but only with triangles. So we're only going to worry about the triangles. Alright. So there's three types of triangle similarity, and so there's only three types of proofs that you'll ever have to do with these. Okay? We talked about one of these at the end of the last video when we discussed proportions, and that one is the side-side-side similarity. Okay? This is where when we show all the sides are proportional, then we can say that the triangles are similar. Okay? Another type is angle-angle similarity. All this is if we can show that two of the angles in a triangle are congruent, then that means that the triangles are similar. And then the third type is side-angle-side similarity, in which if we could show that two sets of sides are proportional and that the angle or the included angle between those sides are congruent, then we can say that the triangles are similar. So let's look at some examples. Okay. So here's another example of a side-side-side proof. So this is what we're given. We're given this picture. Okay. So essentially we're given that AC is equal to 14, AB is equal to 21, BC is equal to 28, and we're given that DE is equal to 10, and that FE is equal to 15, and FD is equal to 20. Okay, so that's what we were given. Well, now off here to the side, I'm just going to do a little bit of work. So I know that AC corresponds to DE. So I'm going to do 14 over 10. And the question I'm asking, is that equal to AB over FE, the two that correspond? And then is that equal to CB, which is 28, or BC, however you want to think about it, over FD, which is 20. Okay, well, I'll reduce this one, divide by 2, and that's 7 over 5. This one, I can divide these by 3, and that's 7 over 5. This one, I can divide by 4, and that's 7 over 5. So then we can see that these are proportional because they're all equal. The ratios are all equal to each other. So then we can say in part 2 that AC over DE is equal to AB over FE is equal to BC over FD It's a property of proportionality. Property of proportions, however you want to word it. So then, because those are equal, then I can say that triangle ABC is similar to triangle DEF by side, side, side similarity. Pretty easy. So we just write down what we were given, kind of do some scratch work on the side to make sure they match up. If they do match up, then we can say this, and then we can say that they're similar by side, side, side. Easy 3 steps. 1, 2, 3, done. Alright, let's look at another one. Here's an angle-angle similarity. So they give to us that angle ADC and angle BEA are right angles. Okay, well, that's what's given to us. These two are right angles, so I could say that ADC and BEA are congruent to one another. Why? Well, all right angles are congruent. Right angles equal 90 degrees. 90 degrees is equal to one another, so they're congruent. Okay. Now, because I'm trying to prove that ADC, triangle ADC, and triangle AEB are congruent to one another, or rather similar to one another, I'm looking for another angle besides these two that they share. Well, they both have this angle A in them right here. And one of the things that I can say is that angle A is congruent to itself by the reflexive property. Okay, so always be on the lookout for stuff like that, especially when triangles are overlapping. Well, now I've got 1, 2 angles, and that's all I need, and I can say that triangle ADC is similar to triangle AEB by angle-angle similarity. Okay? Easy peasy. 2 angles congruent to one another, angle-angle similarity. Last one. Got side angle side triangle similarity. This one's probably the more difficult of the three, but it's really not that bad. So, they give me that AE is equal to 8, which is equal to AEB, so both of these are 8, and that triangle AED, so the little triangle, and triangle ABC, the bigger triangle, are isosceles. Okay, so that's my given. Then I know that AE is equal to AD, and I know that AB is equal to AC, because those are the sides of the isosceles triangles, the smaller one and the bigger one. And we know that the sides of isosceles triangles are congruent to one another, or equal to one another. So that's the definition of isosceles. Okay. I also know, in the same way as the last one, that this angle is congruent to itself by the reflexive property. So when triangles overlap, that's very common to find that there's angles that are congruent to themselves using the reflexive property. Okay. Okay. So then I know that these triangles are similar to one another by side angle side similarity. And you're probably sitting there saying, well, how do I know that, Mr. Wicklehouse? Okay, so let's talk about it a little bit more for a minute. Go a little bit more in depth. This side is 8, so this side is 8. This side is 16, so this side is 16, because these are isosceles triangles. So that means that this 8 over 16, I'm asking, is that equal to the other one, 8 over 16? Well, obviously it is. This is 1/2 equals 1/2. So these sides here are proportional to one another. Okay. So then I have side, angle, side, similarity. Okay. If you want to add this stuff in here, we could say 3.5. We could say that AE over AB is equal to AD over AC. 3.5 property of proportions. If that makes you feel better. Okay? As long as all the pieces are there and it makes sense and I can make sense of it, then I'm good with however you want to do it. Alright, that's it for today. I'll talk to you later.